Okay, so we are talking about solving systems, using elimination again, only today, all of the problems that you're going to see, you have to multiply to get opposites. You have to multiply to get opposites. Yesterday, if we did any multiplying to make opposites, we only had to multiply by what? Yeah, -1. We had the same coefficient. Today, we're going to have to think about factors that give us the same coefficient. We're going to have to do some multiplying to get the same coefficient, all right? And then we just solve as normal. So let's look at this first one. And I just want to write down some notes. So if we wanted to get rid of, because you can do two different things. If we wanted to eliminate the x's, what would we have to do? Multiply by a -3. I would have to multiply this bottom equation by a -3. Okay? Do you see that? Let's do it. Let's do it. Let's multiply by a -3. So I'm going to keep, are we all on the same page? Is this where we should be? Yes? Okay. So I'm going to keep the first equation, 9x plus 12y equals 3. I'm not doing anything to that. To the second equation, I'm multiplying everything. By -3. -3 times 3x is -9x. -3 times 4 is -12y. And -3 times 2 is -6. So Aiden and Violet are both like, I don't think we can do that because when I add these two together, what's 9x minus 9x? 0x. This cancels out. What's 12y minus 12y? So I have 0 equals, what's 3 minus 6? -3. Does 0 equal -3? No. That means they don't equal each other. And that means this is no solution. Let's think about what I know about systems that have a no solution, because this is called special cases. Do you see that? Special cases. Let's see. I know that if it's no solution, the lines are parallel to each other on the graph. I mean, that's what that means, right? If I were to graph these, the lines would be parallel, which means the lines have same what? Parallel lines have the same slope. Yeah. It means that the lines are going to have the same slope and different y-intercepts. Different y-intercepts. Same slope and different y-intercepts. So not every system is solvable. Not every system is solvable, and we learned that from when we graphed, right? We saw that when we graphed equations, systems of equations, sometimes we ended up with parallel lines, okay? So today we're going to talk about the special cases. Let's look at number 2. Number 2. Okay, so if I wanted to eliminate the x's, what could I multiply by? I could multiply by 5, the first equation by 5. Let's do that. So let's see. 5 times -2x is -10x. 5 times -4y is -20y. And 5 times 2 is 10. And then I'm going to rewrite the second equation. 10x plus 20y equals -10. So what do we end up with? 0 equals 0. And I heard someone say it. Say it again. Whoever said that. Was that Gianna that said that up front? Infinitely many solutions. Infinitely many solutions, right? Because it's true. 0 does equal 0. That gives me a true statement. Okay? 0 does equal 0. So what does this look like on the graph? What does infinitely many solutions look like on the graph? Because I'm not sure. Yeah, it's one line graphed directly on top of the other line. So what does that mean about their slope and their y-intercepts of the two lines? What does that mean? If they're graphed directly on top of each other, what does that mean? Yeah, good job. That means that the slopes are equal and the y-intercepts are equal for both equations. So when we talk about special cases, remember when you get something weird like a no solution, think about what that means. That means that your lines are going to be parallel to each other, right? They're never going to intersect on the graph. Or if you get something that gives you a true math statement, this is a true number statement. That means that you're going to have infinitely many solutions, which means that the two lines lie directly on top of each other. They lie directly on top of each other. Okay? Questions? Who needs more time with that? Okay, I want everyone's heads up. I'm not going to ask again. Heads up. I want you to pay attention. Thank you. Everybody, heads up. Okay, so let's look at this next one. I need to have opposite coefficients. Do you want to try and get rid of the x's or the y's? We have to make a choice. Which one do you think would be easiest to get rid of? X's? Noah, you want to get rid of the y's? So Noah, let's look at this for a second because I think it's a good thing to talk about. If we wanted to get rid of the y's, what would I have to do to make both of these opposites? What would I have to multiply the top equation by? Noah? What would I have to multiply that top equation by? Because I need the 2, that -2 and the 3 to be the same number. What could I multiply the top one by and the bottom one by so that I get the same number, the product? So a trick is multiply those two numbers together. What's 2 times 3? 6. So if they both equal 6, one's a positive 6 and one's a negative 6, we can cancel them out. So if I take that top equation and I multiply everything by 3, 3 times 2 is going to give me my 6, right? And then I would have to multiply my bottom equation by 2. Let's do that. Let's try that. That's okay. That's all right. I'm sure that we're all learning, okay? So every single thing in this equation is getting multiplied by 3. 3 times negative x is negative 3x. 3 times negative 2y is negative 6y. And 3 times 2 is 6. Let's look at the next equation. Multiply every single thing by 2. 2 times negative 2x is, anyone? What's 2 times negative 2? Negative 4x. What's 2 times 6y? Sorry, what's 2 times 3y? 6y. And 2 times 4 is? Hey, are you guys awake out there? Okay. So I'm going to add these two equations together. I'm eliminating the y's. Do you see, Noah, how now you've made us have the opposite coefficients on the y's? So when we add these two together, I eliminate my y's. What is negative 3 plus negative 4? Negative 7. Negative 7x equals 6 plus 8 is 14. If I divide both sides by negative 7, I find out that x equals negative 2. Okay, Seamus, I'm going to call on you because we got this far with our homework and then we hit a wall, right? So I want you to think about, I know that x equals negative 2. So in my ordered pair, x equals negative 2. What am I trying to find? If I know what x equals, Seamus, what am I trying to find? what's the other part? Yeah, I have to find y. So the only way to do that is to take either one of these equations. I'm going to take the first one, negative x minus 2y equals 2. And I'm going to substitute in this negative 2 right there for the x, because I know that x equals negative 2. So let's do that. I have a negative outside of my x. We make a lot of mistakes when we have a negative and then we plug in a negative. So whenever I substitute in for a variable, I put it in a parenthesis. The value of x is what? What are we substituting in for x? X is really what? We just solved it. It's what? It's negative 2. So I have negative 2 minus 2y equals 2. So what is negative times a negative? So that really turns us into a positive 2 minus 2y equals 2. What do you want to do next? Take away, so subtract 2 from both sides. Subtract 2 from both sides. And what? So negative 2y equals 0, which means what? It's not wrong. We divide both sides by what? What are we dividing by? Negative 2. Yeah, you always divide by the number attached to the coefficient. That just means that y equals 0. Is 0 a number? Yes, it is. 0 is a number. We can have 0 as a number. So our ordered pair is the ordered pair negative 2, 0. Our ordered pair is the ordered pair negative 2, 0. Okay? Let's do it again. Let's do it again. Let's look at number 4. We did word problems. We cut up 8 word problems. That was our warm-up today, and everybody had to do one. It was fun. It was fun. We went through every single one of them. It was good times. Okay, let's look at this one. What do you think would be the easiest thing to do to get rid of one of the variables? What could we do to get rid of one of the variables? What do you think? Say again. Yeah, I think that we could multiply the top equation by 4 and we'd be done with it. I think that's an awesome idea. So let's see. 4 times 3x is 12x. 4 times 5y, 20y. And 4 times negative 14 is negative 56. I'm going to rewrite the second equation. Negative 12x minus 8y equals negative 28. Negative 12x minus 8y equals negative 28. When I add these two equations together, what do I get? What happens? Yeah, the x's cancel out. I have 20 minus 8, which is 12. So that gives me 12y equals, same signs, add them together and keep the sign. Negative 84. Negative 84. So I'm going to do what next? Yeah, divide both sides by 12. What is negative 84 divided by 12? Negative 7. Good job, Aiden. It's negative 7. Negative 7. Okay. So I'm trying to find x. I heard someone say that we got to get x. We got to find x. So what equation? Let's just use this top equation. 3x plus 5y equals negative 14. So what am I replacing my y with? What am I replacing my y with? Negative 7. 3x plus 5 times negative 7 equals negative 14. 3x, let's see, 5 times negative 7 is negative 35 equals negative 14. Gianna, what do you want to do next? Oh, I think that sounds great. Let's add 35 to both sides. So 3x equals 21. 3x equals 21. What would you like to do next? Divide both sides by 3. Divide both sides by 3. And I find out that x equals 7. So what's my solution? It's the ordered pair 7, -7. Absolutely. What do you think about that? You think it's beautiful? Okay. We're going to do number 5 and number 7. Number 5 and number 7, and then we'll get started on our homework. Number 5. Number 5. We're going to have to change both like we did on that first equation that Noah told us to get rid of the y's. We're going to have to change both equations. So you just need to decide. You notice that both the x's are opposite. One's positive, one's negative, and both of the y's are opposite. One's positive, one's negative. So we're just going to multiply by 2 positive numbers. If you can't think about what you're trying to do, take the 2 numbers and multiply them together. 2 times 3 is 6. So that means I have to multiply this top equation. I took 2 times 3, and I took 3 times 2. That's how we do it. Okay, that's how we do it. So let's see what we can get. 3 times -2 is -6x, absolutely. 3 times -5y is -15y. And 3 times 15 is? Good job. Okay. What about 2 times 3x? Positive 6x, that's good. We got opposites there. 2 times 2y? 4y. And 2 times 28? 56. Okay, so when I add these 2 equations together, what am I canceling out or what am I eliminating? Yeah, those x's. -15 plus 4 is -11. So I have -11y equals, let's see, 5 plus 6 is 11. Carry my 1. That looks like 101. 9, 10. Yeah, 101. Okay. So what am I going to do now? Divide both sides by what? -11. And what happens? You get a decimal. Are we allowed to have a decimal answer if it's not terminating? If our decimal doesn't terminate, if it doesn't end, can we use that decimal or do we have to keep our answer as a fraction? We have to keep it as a fraction, and that's a stinking ugly fraction. I'm going to be real honest. That's a hideously ugly fraction, but we're going to use it. Notice that I'm going to take that negative that's in the bottom and I'm going to move it to the top because I don't want to forget that my fraction is negative. Oh, yuck. That's going to be awful, but that's okay. We can work with it. So I have to find y. No, sorry. I have to find x. Yeah, you guys are awesome. So I'm going to use this equation right here because I don't want to have to mess with negatives. Is that okay? Notice how I chose the equation that just has all positive coefficients. I'm going to try to make it a little bit easier. So 3x plus 2y equals 28. All right, so 3x plus 2, I'm writing as 2 over 1. Why am I doing that? Why am I turning that whole number 2 into 2 over 1? Any ideas? Yeah, I'm trying to make it a fraction because I want to take a fraction times y, which is a fraction. I want it to look like a fraction times a fraction. That makes my brain happy. So -101 over 11 equals 28. How do I even do that? Well, you multiply fractions straight across, right? And the whole number 2 is the same thing as 2 divided by 1. So I can just put the whole number 2 over 1. So let's see what that looks like. That gives me 3x plus, let's see, 2 times -101 is negative 202. And 1 times 11 is 11 equals 28. Okay, so I know that I'm going to have to do what to both sides? Not yet. What do I have to do with that hideous fraction? I have to, it's already a negative, Noah, do you see that? So I'm going to have to add it to both sides. So before I do that, I know that if I add fractions, they have to have a what? What do I know about adding fractions? What do you remember about adding fractions? Common denominator. So I'm going to show you a trick. I'm going to take 28 over 1 and I'm going to multiply it by this fancy looking one. 11 over 11 equals what? What's 11 divided by 11? It's 1. It's just another way to write 1, right? So I'm going to do that so that way I have a denominator of 11. So I need someone to take their calculator and tell me what 28 times 11 is, because I have tired brain and you don't want me doing that math. 308 over 1 times 11 is 11. And to that, remember, we're adding, I'm just going to rewrite it underneath here. We're adding 202 over 11. That's what we did, right? So on this side, I have 3x equals, what is 308 plus 202? 510 over 11. Okay, almost done. Almost done. Typically, we divide by the number that's attached to the variable, right? But if I write divide by 3, what if I wrote that looking like this? I'm going to try something. You tell me if it makes sense. Instead of dividing by 3, because I want that number in front of the x to equal a 1, what if I multiply by its reciprocal, 1/3? What is 1/3 times 3? Or 1/3 times 3 over 1? Well, let's multiply it out and see if this makes sense. 1 times 3 is 3. And 3 times 1 is, and what is 3 over 3? 1. So that gives me my 1x, which is what I want. So if I'm going to multiply the left side by 1/3, I have to multiply the other side by 1/3. So 1x equals, well, let's see, 510 times 1 is 510. 11 times 3 is 33. Put that into your calculator, please, and thank you. And let's see if we can simplify that fraction. So just do 510 divided by 33, and then hit the math button to get a fraction. Hit the math button to get a fraction. 70 over 11. Good job. X equals 70 over 11. Oh, 170? Yeah, cool. 170 over 11. So my ordered pair, 170 over 11 and negative 101 over 11. This is a perfect example of why graphing doesn't always work. If we were to graph that, would you be able to look at where my two lines cross and say, oh, that's 170 over 11? Absolutely not. Absolutely not. And I know that was really tedious, but sometimes you're going to get fraction answers, okay? Sometimes you're going to get fraction answers. I want to do this word problem because I told you guys, I promised you we're going to do a word problem every day till you feel comfortable about it. So I need someone to read because I need to take a drink. Reader, anyone, go.
At a sale on winter clothing, Cody bought 2 pairs of gloves and 4 hats for $42. Corey bought 2 pairs of gloves and 2 hats for $30. What were the prices for 1 pair of gloves and 1 hat?
So the question is, what am I trying to find? The price for a pair of gloves. So X is the price for a pair of gloves. Write it down, define your variables. And what is y going to be? The price of one hat. Okay. I underlined some stuff up there. We're buying something plus something else for a total. What am I buying? What's Cody buying? What's it say Cody's buying? 2 pairs of gloves. What variable represents the cost of one glove or one pair? So 2 times the cost of gloves plus how many hats am I buying? 4 times the cost of a hat equals, how much money did Cody spend? $43. Okay, awesome job. I am not going to help you with the second one. Someone, you guys think about it and someone come up with the equation. I know you can. Look at what they're buying. See what Tori's buying. Jaden, who was that? Gianna, perfect. 2x plus 2y equals 30. Absolutely perfect. Absolutely perfect. Okay. We're not going to solve it. I just wanted to make sure that we could write an equation. We spent enough time with word problems. Okay. So let's look at our homework. I'm going to go back to our module. I might need to adjust to make sure it's productive. So our homework, we're definitely not going to get to this digital maze practice. That's fine. I'll just move it away. I'm going to leave it there because I offered some kids that as extra credit. Some kids finished everything yesterday, but our homework is pages 16 through 18. Can we talk about that?